In this
video, I will show you how you can commission SIMATIC PCS7 automation projects virtually using SIMIT simulation framework. First of all, I need an overview of the way in which the plant behaves. I have to understand which devices, in other words, actuators and sensors, I have in my project and how they behave in physical terms. In the example, liquids are pumped from 3 raw material tanks into 2 reactors. The volume flow is determined by the pumps and the controllers. The mixed liquids in the reactors are heated using heat exchangers. Agitators, controlled by dynamics, are used to produce the final product. The product is then transferred into bottles via a piping system. A SIMO Pro is used to boost the pressure in the piping system. A conveyor system underneath transports the filled bottles to their final destination, where they are sealed with crown caps. Now that I am familiar with the plant, I can start the virtual commissioning process. The first step involves manually testing the signals in the control system. To do this, I first export the symbol table from PCS7. In this example, the control system is represented by an emulated controller, which means that the hardware configuration does not need to be exported. This would be necessary for a hardware-in-the-loop solution. Then I add a new coupling to the emulated PLC SIM controller in SIMIT and import my symbol table. This adds all the addresses and symbolic names automatically, which means that I can start the I/O simulation immediately. For example, I can manually test the signal connections in my automation project. If I want to test my automation project further on, for example, the feedback, alarms, warnings and hysteresis, in the next step I can export the entire technological hierarchy, including all the control modules, into an XML file. Immediately after this, I can import all my actuator and sensor models on the basis of the templates in SIMIT, which correspond with the process tag types in the PCS7 library. Using the previously exported XML file, the simulation models of the control modules are added as simulation diagrams in a technological hierarchy identical to that of the PCS7 project. Next, I can start the simulation in order to test all the feedback. For example, I can immediately test local operation and all the motor functions such as trip and maintenance. Using a component I have created myself, which generates a signed signal, I can also test the alarm thresholds, warnings and hysteresis. Using the trend, I can record the controlled variable of the PID controller in order to analyze it. This means that it is possible to test the entire field level of an automation project functionally and qualitatively with very little effort. I can refine my simulation project even further, so that it can be used to test sequence controls or to provide basic training for operators. On the so-called process level, I can represent physical behavior in the form of simulation models. However, first, I need to determine the requirements that a simulation model of this kind must meet. In the case of many virtual commissioning processes, a simple process model with standard components is often sufficient. However, if the behavior is more complex or needs to be represented more realistically, I can opt for the FlowNet library, which is specially designed for process technology. Alongside standard and FlowNet components, SIMIT also offers the option of defining your own simulation components with the component type editor. In this example, I have used all three modeling variants. In other words, simple modeling, using components from the standard library, realistic modeling for process technology with FlowNet to simulate code commissioning, and modeling with the component type editor to create my own components. When all the process models have been developed, I can start a simulation and test my sequence control. I can monitor the raw material tanks as they fill up and then watch the liquids being pumped into the reactors. I can also check that my interlocking functions are operating without problems. For example, the script simulates an uncontrolled rise in temperature in reactor 1, which results in the valve being unlocked. This gives the operator the opportunity of opening the valve manually to reduce the temperature. This makes it easy for you to define a basic scenario for training the operators before the real plant is commissioned. After the liquids have been heated and mixed in the reactors, they are transferred into bottles. The conveyor system below was simulated using the optional contact library in SIMIT. The conveyor transports the filled bottles via the switch to their final destination. Finally, the 3D model sends feedback about the process of fitting the crown caps. The SIMIT identification systems, such as the RFID components, allow me to send this information to PCS 7. In the PCS 7 OS, there is a message indicating that the bottle is ready to be transported. Virtual commissioning of SIMIT simulation framework PCS 7 automation projects. Fast, flexible and easy.